Hello everyone, presentation of conference paper on the title Optimization of Compressive Strength of Sancrete Block containing coconut shell ash as cement partial replacement. Authors Chijioke Ikeagwuani, Udeme Udokpoh, Michael Ebie Onyia, all from the Department of Civil Engineering, University of Nigeria, Nsukka, Enugu State, Nigeria. The conference paper is presented by Udeme Udokpoh. Introduction. The major component of a building is the walling material. These walling materials can be made of glass, wood, or composite material such as sandcrete block. The composition of sandcrete blocks are fine aggregates, binders, and water. This binder could be cement. These constituents are homogeneously mixed in standard proportions. They can be molded either as solid or hollow rectangular shape. The quality of a good sandcrete block is determined by its compressive strength parameter. The Nigerian Industrial Standard 2017 recommends 3.5 Newton per millimeter square as the minimum compressive strength at 28 days for load-bearing walls and 1.5 Newton per millimeter square for non-load-bearing walls. Cement, which is used as binder in the production of sandcrete block, is becoming uneconomical and unsustainable. The soaring cost of Portland cement, which is an essential construction material that is used principally as a binder in cement-based construction, has necessitated the need to find replacement for it, either partially or wholly. Replacement of cement assists greatly to drive down the cost of construction as well as to cause a reduction in greenhouse gases generated during its production. The reduction in sandcrete block production cost may be achieved by partial replacement of cement with economical pozzolanic materials. Studies have shown that most materials such as coconut shell ash and rice husk ash, which are rich in amorphous silicate, can be used as partial replacement for cement. Despite the improvement in the strength properties of sandcrete block produced after adding economical additive, no researcher has incorporated optimization technique to improve the constituents of sandcrete blocks in order to achieve optimal results in the strength property. It is against this backdrop that these studies seek to integrate Taguchi method and optimization techniques to enhance the compressive strength of sandcrete blocks used in practice. Taguchi method for the optimization of process parameter is an effective tool that is being utilized in most industries since its introduction in the designs of experiments. Taguchi approach is an offline quality control technique done to improve the production and reliability of a product as well as to cause a reduction in its lifetime cost and product development. Materials and methods. Materials. Water. Potable water was used both in the production of sandcrete blocks and for curing. The potable water was free from harmful acid, alkaline, and organic materials. Fine aggregate. The fine aggregate was collected from a sand deposit located in Enugu State, the eastern part of Nigeria. Where the fine aggregate was obtained can be classified as pit sand. Portland limestone cement. Portland limestone cement used as binder in the sandcrete block mixture was obtained commercially in Nsukka, Enugu State. The cement grade was 42.5 Newton per millimeter square and met the requirements of Nigerian Industrial Standard. Coconut shell. The coconut shell used in the production of coconut shell ash was sourced locally in Nsukka.
Figure 1 is the burnt coconut shell ash removed from the furnace after calcination. It will be crushed into powdery form using a crushing machine, while Figure 2 is the Portland limestone cement that was used in the sandcrete block mixture.
Table 2 shows the chemical composition of coconut shell ash. From this table, it is evident that coconut shell ash is rich in amorphous silicate, which it can be used. Methods: production of coconut shell ash. It involves two stages, the preparation and the carbonization. In the preparation stage, the coconut shell will sun-dry for a duration of 1 week, thereafter breaking them into smaller fragments with the aid of a hammer. It was sprayed in a tray and further allowed it to dry under sun for 3 days to remove entrapped moisture. In the carbonization stage, the shells were transferred into the furnace and incinerated at a temperature of 400 degrees Celsius. After burning, the coconut shells were removed from the furnace and allowed time to cool. It was ground into powdery form and then made to pass through BS number 200 test sieve. It was packaged in airtight containers prior to usage. Production of sandcrete blocks. The sandcrete blocks were produced using a sand binder ratio of 6.0, 108 150 by 225 by 450 millimeter size hollow sandcrete blocks were produced. The production was done manually. The produced sandcrete blocks were cured for 28 days to allow for strength development. Curing was done by sprinkling water on the blocks twice daily, which was morning and evening. Compressive strength tests. The compressive strength tests were conducted in accordance with BS 6073 Part 1, 1981. Optimization techniques. Taguchi method. Taguchi approach uses two essential tools for the optimization process parameter: signal to noise ratio, orthogonal arrays. Orthogonal array selection. Taguchi mixed level L18 orthogonal array was chosen. The end wave to center wave ratio was given 2 levels, while the water cement ratio and the coconut shell ash were assigned 3 levels. The value of the process parameter were obtained based on experience, brainstorming, and what is obtainable in real-life practice. Figure 1 shows the isometric view of the hollow sandcrete block with end wave to center wave ratio of 1:1. Figure 2 shows the isometric view of the hollow sandcrete block with end wave to center wave ratio of 1:2. The percentage of void in 1:1 ratio is less than the percentage of void that is in 1:2. Table 3 shows the results of the average compressive strength of each of the experimental runs generated from the Taguchi orthogonal array. The compressive strength was slightly higher in 1:2 EC ratio configuration compared to 1:1 EC ratio configuration. Sandcrete blocks produced with 0.55 water cement ratio has higher value of compressive strength with minimum replacement of coconut shell ash. The compressive strength decreases with increase in percentage of coconut shell ash. The same trend of result was observed for 0.6 water cement ratio. For 0.65 water cement ratio, it was found that at 5% CSA replacement, the compressive strength of 4.07 Newton per millimeter squared was recorded. 1:1 end wave to center wave ratio followed the same trend of result. 5% replacement with 0.65 water cement ratio is the optimum replacement level of Portland limestone cement with coconut shell ash. This is because the strength decreases at addition of coconut shell ash. At 20% replacement, the strength made the minimum required for sandcrete block at 28 days by Federal Ministry of Works. The increase in the compressive strength can be attributed to cement hydration and pozzolanic reaction between Portland limestone cement and coconut shell ash. The reaction is prompted with the hydration of cement in addition of water. The most essential factor in the rate of strength gain and formation of cementitious compound is the quantity of water available for chemical reaction process to take place. The water cement ratio is therefore the controlling process parameter which determines the strength that is gained with time. It can be observed from this laboratory result that the compressive strength of sandcrete block produced increased with increase in water cement ratio. It can also be observed in end wave to center wave ratio configuration of 1:1 that the compressive strength increased with increase in water cement ratio. Conclusion. From the laboratory analysis and the result obtained, the following conclusions are drawn. Coconut shell ash possesses good pozzolanic property and such could be used as partial replacement of cement in sandcrete block production. The optimum compressive strength of 4.07 Newton per millimeter squared for the end wave to center wave ratio of 1:2 is achieved with 0.65 water cement ratio and 5% coconut shell ash replacement after 28 days of curing. The optimum compressive strength of 3.93 Newton per millimeter squared for the end wave to center wave ratio of 1:2 is obtainable with 0.65 water cement ratio and 10% replacement of coconut shell ash after 28 days of curing. Sandcrete blocks produced with end wave to center wave ratio of 1:2 gave higher value of compressive strength compared to sandcrete blocks produced with 1:1 end wave to center wave ratio. The optimum replacement level for Portland limestone cement and coconut shell ash is 5%. The blocks with 10% coconut shell ash replacement should be used for low-income housing. Blocks produced in this study can be used as walling units in areas exposed to moisture such as groundwater, and it can also be used as load-bearing wall. Thank you for the audience.